Hello everyone. In this lecture, we will learn to write a 8051 program to find a largest number or a smallest number in a array of data. So let's take 5 numbers as 05H, 07H, 0AH, 08H, and then 20. Okay, now let's first compare two numbers here, right? So if we compare 5 and the 7H, the largest number is 7H. So for the next comparison, we need to keep 7H as a reference data, and we'll call this one as a first iteration of the comparison. And in the next iteration, we need to compare 07H with the 0AH, and the largest number again will be considered as a reference number for the next comparison. So here the greatest number is 0AH, and we'll call this one as a second iteration, right? And next 0AH will be compared with the 08H. Among these two, 0AH is the greater number, and for the next comparison, we'll keep 0AH as the reference number, and we'll call this one as third iteration. Okay, and next 0AH will be compared with the 20H, and in these two, the 20H is the greater number, so that will be stored in some memory location or wherever we want. So among these 5 data, the largest number which we got is 20H. Okay, so now let's assume that these data are stored in the internal RAM memory location starting from 30H. Starting from 30H, 31H, 32H, 33H, and 34. Okay, and now the result will be stored in 60H. The result will be stored in 60H. And also note that when you are writing the program, always we will keep the largest number as a reference in each comparison, and that will be stored in the 60H. Means nothing but in each time the data, the reference number will be stored in 60H. Okay, right? So now, for example, right? So now, okay, first we'll write the code now, and then we'll see what the comparison instruction does. Okay, right? So now first we need to initialize a counter to point the data, right? So for that we can use the instruction move r0, hash 30H. Move hash, 30H. So this one R0 is initialized to point the internal memory location 30H. So next, now we need, as we use the looping method, we need to specify how many comparisons we are going to do. So that is initialized with the register. I'll take this as R2, and here we are taking 5 numbers. So the number of comparisons are 4. Okay, right? So next we'll load the first data in 60H. So as I told earlier, we'll keep 60H is also one reference location to store the data. So for that, what we have, the instruction is move 60H, comma at R. Okay, so when this instruction is executed, 60H will have the 05H data. Next, we need the one more data, right? Because for the comparison minimum, we need 2 data. So to access this data, first we need to increment our pointer. So that is done by increment R0. Okay, so when this instruction is executed, the pointer will be, control will be pointing to the internal memory location 31H, and now we will access the next data into accumulator. Move A comma at R. Okay, so this is how we got the two data in two different locations. So now we need to compare these two data, means the data present in the accumulator and the data present in the 60H. So for that, in 8051 we have the instruction compare jump if not equal destination comma source comma label. Okay, so this is the opcode we have to compare any two numbers. So what this is, compare jump if not equal. It will not tell whether the number is greater or lesser, but it will jump to the label specified in the instruction if the content of this destination location and the source locations are not equal. Okay, so now for example, for this program, I'll use the CJNE because there are these CJNE instructions will be working with different addressing modes. So for example, there are 4 different instructions are there with the opcode CJNE. So that is CJNE A comma hash data, CJNE A comma direct address, that is web direct address, and next we have CJNE RN comma hash data, and next we have CJNE at RI comma hash data, and all these are having the label, means target address. And at last one more we have, it is CJNE A comma B comma label. Okay, so now here we actually were using the references, actually it's a block of data, so that's why this, wherever we are using the immediate data, those instructions cannot be used. So the instruction which we can use is CJNE A comma direct or A comma B, but I will use this instruction. That is CJNE CJNE A comma direct address. So here we can take any address. So in my example, I am taking it as a 60H. So that is CJNE A comma 60H label. So now whenever this instruction is executed, the internal circuit subtracts content present or data present in the 60H from the accumulator. It's nothing but it's of A minus 60H. So in our case, A is having 07H and 60H is having 05H. Okay, so then depends upon this subtraction, it changes the carry flag. It changes the carry flag. So if A is greater than this data, if A is greater than this data, the carry flag is 0, means we are not taking any borrow to subtract this number from this, and the result is positive. But if A is less than this number, then we need to take the borrow to subtract the data present in 60A. So that's why the carry flag is sets, right? So by checking the carry flag, we can find out which number is a greater and which number is a smaller. Okay, so now we'll use this instruction here. Compare jump if not equal A comma 60H comma label. I'll write just it as L1. Okay, L1, right? So now, as I told earlier, right, we'll keep the largest data in the 60H. Okay, so now we'll take the current example itself where accumulator is having 0.7 and the 60H is having 5H. Okay, right. So now it is, if the numbers are not equal, it jumps to this specified address. That is, I'll write this as L. Okay, right. So now we need to check that whether the A is greater or the data present in the 60H is greater. So that can be done by checking the carry flag. So we'll check the carry flag. Okay, we'll check the carry flag. Right. So depends upon the carry flag, we need to modify our data. Right. So now carry is generated. It's nothing but what actually, the A is less than the data present in 60S. So that time no need to do anything, right? So that is no change. So simply I'll get the next data by incrementing R0, right? If carry is not generated, if carry is not generated, is nothing but the accumulator is having the largest data compared to the data present in the 68. So that time we need to get the largest number in the 68. So that is done by the instruction move 60H comma A. Move 60H comma A. Right. So now after this one, as usual, we need to get the next data. We need to increment R0, right? And then we need to check the content of R2 register, whether we have done all the comparisons or not. If the R2 is not 0, then we need to repeat the instruction from move A comma at R0, that is to get the 0A in accumulator, right? So now here one thing is left out, right? So here we are seeing that if the numbers are not equal, it jump to the target address. For example, if the numbers are equal, then what we need to do? Then we no need to do anything, right? So we no need to do anything, just we have to start from this, right? So we can write it is test gem no change, so that will come here. Okay, then as it will increment the R0 and it will check for the R2 register, and then it does according to the label what is represented. Okay, right. So this is how we can implement, we can write a 8051 program to find the largest number. Okay, so in the same way we can find out the smallest number also, right? So just we need to do one change here. Instead of carry flag JC, we'll use the JNC. We'll use the JNC. So then that time with the smallest number will be present in the 60. Smallest number will be present in the 60H location. Okay. So now we'll see this example by executing in the Keel compiler. Okay, the numbers are loaded in 30HR, 05H, 7H, 0AH, 08H and 20H. So now we'll see the step-by-step execution. So the first R0 is initialized. R0 is initialized as a pointer to point the 30H location. So after execution of these instructions, R0 should be loaded with the 30H. Then we are using R2 as a counter to store the number of comparison. So R2 is initialized with 04X. So next we are storing the largest data in the 60H. So and we are using the 60H as a reference location also for comparison. So first we'll access the first data into 60H that we can see here. Okay. Right. See now the 60H is having 05H. And now next we need to get the next data. So that is to be done by, first we need to implement the pointer to point the next data, and then that data is we are copying into accumulator, right? So now the A is having 07, right? Now now the execute this CJN instruction will compare A and 60H and we will change the carry flag. Now we'll see what happens to the carry flag. So at present the A is having 07H and 60H is having 5, means A is having the greater number compared to the 60H, so the carry flag will not set, right? So we will check. Yes, see, these numbers are not equal, so it jumps to the label L1. So then in L1 we are having the instruction JC. Now it will check the carry flag, right? See, when this instruction is executed, if the numbers are not, if the A is having the greater number, then the carry flag will be reset. If the A is lesser, then the carry flag will be reset. But contents of accumulator and the 60H remains same. Only it affects the carry flag, right? So now we'll check the carry flag, right? So if the carry flag is 0, it is nothing but the accumulator is having the, sorry, if the carry flag is set, that is, if this JC instruction, what it does means, if the carry is set, if the carry flag is set, it jumps to the label specified in the instruction, that is next. It will jump here, right? So now in this case the carry is not generated, so after execution of this instruction we expect our controller to point the instruction, that is DJNZ, right? Sorry, yeah, if the carry is not generated, right? If the carry is not generated means the condition failed, so it will execute the instruction which is below the JC instruction. So that's why we have the control here, right? Means what we are doing, we are moving the larger number into 60H, because we are using 60H is a reference location to store the largest number for the next comparison. So for the next comparison we need 07, because among these two numbers 07 is the larger number, so that we are copying into 68, right? See, now 68 is having the 07H. Now we need to check whether all the comparisons are not done or not. So what this instruction will do, first it will decrement the R2 register, then it will check for 0, right? See, now R2 became 3, but it is not 0, so that's why it will jump to the label specified here, that is, here we have it is L2, so L2 is represented here, right? So now it came here, right? So now next the pointer is pointing to 32, that is 0AH, we are copying that into accumulator. So now accumulator is having 0AH. So now the A will be compared with 7H, right? A will be compared with 7H. So now A is the larger number and the 60H is having the lesser number, right? So now, see, in this time the carry is sets, because A is the larger number, right? So that is now, yes, same moves. Again we are getting the data into 60H, right? So now the R2 is 02, so still it is not 0, so it will again, it repeats the instruction from move A comma at or not, right? Now move A comma at or, right? So now this next location is 33, and 33 is having 08, and that will be loaded into accumulator. So accumulator is loaded with the 0AH. So now in this case the carry is generated, right? Means the 60H is will have the largest data, so that time we no need to do anything. It means we don't need to execute move 60H comma 8. So directly we can decrement this register, and if it is not 0, then we can repeat the loop, say, right? Now just you see this execution. Now first these two numbers are not equal, so it will jump to this address. Yes, right. See, now you can see the status of the carry flag. Carry flag is sets, means this carry flag is sets means that this condition is true, so it will jump to the label present here, that is next. Yes, see, we got the controller to this instruction, then it will, right? So R2 is now 1. Again it repeats this loop. It will access 20 into the accumulator, right? See, now you came to the end of this execution, and we can see that the 60H is having the 20H, which is the largest data among all the numbers. Okay, so now in this example itself we will see the smallest number. Okay, so for that we need to do the changes. Instead of JC we will do the JNC. Means again 60H we are using to store the smallest number and also as a reference location. Means whenever the accumulator will have the lesser number, so that time that will be moved into 60H. But if A is 60H is having the lesser number, that time no need to do. That's why you are using the JNC. If carry is not generated, is nothing but A is the larger number and 60H is the smaller number, so no need to do anything, just repeat the loop until all the comparison done. In case if the A is having the lesser number, means if this condition is failed, then we need to get the smaller number into 60H. So that we'll see by executing this. Let us store the numbers, same numbers, 0, 5, 7, 8, 8 and 20. So here among these the smallest number is 5. So after completion of execution, 60H should have 5H. So we will see that. Right, so actually first we are comparing 5 and 7H, means 5 is present in 60H and 7 is present in the accumulator, right? So now if these two numbers are not equal, so it jumps to this here. So now here you can see that whether carry flag is set or not, right? So if the carry flag is resets, it's nothing but A is having the greater number and 60H is having the less number, so no need to do anything, means we need to keep 5H remains in the 60H, right? So the control came to this one, just it will decrement R2 and it repeat this instruction, right? So now next case, 0, 5 will be compared with 0, AH. Again 0, 5 is the lesser number, so that time also will not be doing anything, right? So now next A is having the 0, 8H. Again 0 in among 0, 5 and 0, 8. 0, 5 is a lesser number, no need to do anything. So here the controller directly come to the instruction DJ NZ. And at last now A is having 20H. Again 20H is the greater number compared to 60H. So that this time also we no need to do any changes, right? So directly after this L1, then it comes to the instruction DJ NZ, right? So now its execution is finished and 60H is having the data 0, 5, 6. So now you can try by using the different set of the numbers.